Good day, students. Welcome to class. I'm so happy to have you back. Today we are still under the topic force and motion, dealing with the subtopic falling and turning. But let's deal with falling through the air. How do objects fall through the air? Let's give some background before we do some exercises. Objects fall to the ground because they have weight. The weight of object is caused by the gravitational field of the earth pulling downward on their mass. Let's deal with this question, the words. Moon's gravitational field is weaker than that of the earth. Objects weigh less when they are on the what? Moon. Let's see. It is necessary to study the direction of forces acting on an object. So let's check. That is it, correct. Now, let's move on. All objects, can that be true? We'll see later. Fall with the same acceleration, provided no force is acting to reduce their acceleration. Let's check. That's true, correct. Let's move on. So, for many objects, the force of air resistance can affect their acceleration. This is illustrated with the use of a parachutist falling from an aircraft. Before opening the parachutist can reach a terminal velocity of 50 meters per second. You can see from the diagram. So, this describes the forces on a falling parachutist. The acceleration is upward as the parachutist is coming down. Air resistance acts upward, weight acts downward. But at a certain time, the air resistance and the weight becomes equal in air. But by the time the parachutist is about to reach the ground, the air resistance becomes greater than the weight. And by the time the parachute is released, the air resistance and the weight becomes equal before the parachutist now land. With this, we can then prepare a speed-time graph for a falling parachutist. Now, speed is in relationship with time. From the graph, we can see that while the object or body is falling from the plane, this place from the graph indicates an increase in what? Velocity. Increase in velocity. While this area shows what? Steady speed. While the parachutist is falling, while he opens his parachute, he does what? Loses, he has more air resistance now. He has more air resistance than weight. That is why we have this place to be curved. But by the time the air resistance, let me call that AR, is equal to the weight before it lands, that's why we have this straight line. So we can see about 4 phenomena all happening together from the time the parachutist leaves the plane till it reaches the ground. till it reaches the ground. Now, moving on, looking at the speed time graph below, find a point where the graph is sloping upwards. So this is the point where the graph is sloping upwards from here to here. Is the parachosis accelerating or decelerating? At first, it is accelerating from here to here, maintaining this steady speed here. Now, which of the two forces acting on parachosis is greater? By way of descent, when it first of all started, the weight was greater than the air resistance. But later on, by the time it was about to finish its descent, the air resistance become greater than the weight. And by the time it land over here, the weight and the air resistance and the weight are equal. So after the parachute has been opened, the air resistance and the weight becomes equal. That's why it's able to land, to stay on the ground. Now, as you can see also here the speed is increasing, and that is with what? The point where the graph is slowing upwards. At B now, for the question B, at the start, the parachosis is accelerating. At C now, after the parachute is open, the acceleration of the parachosis goes upwards. The parachosis went through deceleration, which changed with decreasing height. Now, going round in circles. When a car turns a corner, it changes direction. Any object moving along the circular path is changing direction as it goes. A force is needed to help change direction. The force that keeps an object moving in a circle always acts towards the center of the circle. If the force disappears, the object will move up at a tangent to the circle. It will not fly outwards, away from the center. For instance, an aircraft tilts to change direction. The lift force on its wings provides the necessary force. This is illustrated below. Here also, a sideways force holds the aircraft in its circular path. This is it. We have the lift on its wings, and we have gravity acting at the center. Now, let's deal with this activity. The diagram shows a bird in flight. In which direction does the weight of the bird act? Like we made mention earlier in our previous interaction, the weight of any object will always act downwards. So D would be appropriate. Let's see. Let's check. Correct. Moving on. Looking at this table, we have planets and their weight of a 10 kilogram mass that is placed on this planet, how they vary. For Mercury, we have 40, Venus 90, Earth 100, Mars 40, Jupiter 250. The table shows the weight of a 10 kilogram mass on each of the 5 planets. On which planet would an astronaut have a smaller weight than on Earth? Now, what we do here is to look critically at the respective weight that we have, in the sense that gravity of these planets will have been considered. Then we can then pick the ones that are smaller than that of the Earth. For instance, on Mercury we have 40, Venus 90. On Mars also we have 40. Earth and that of Jupiter is higher. So our answer now will be what? Mercury, Venus, and Mars. So let's check. Correct. Moving forward. Now, looking at this, let me enlarge it a little. Yes. Now, these are weights. The weight of four objects 1 to 4 are compared using a balance. Which object is the lightest? That is, which object has the smallest weight? If you should look at it, by the virtue of what is called balance, any object that has the smallest weight is always raised up. The one with the largest weight is always down. So with this in mind, I can say that weight 1 is greater than weight 2. Weight 3 is greater than weight 2, while weight 4 is greater than weight 2. Also, if I need to reverse this, I can also say that weight 2 is lesser than weight 1, weight 2 is lesser than weight 3, and weight 4 is greater, is lesser than, is greater than weight, is lesser than weight, weight 2, sorry, weight 2 I can then say that weight 4 is lesser than weight 2. With that in mind, then weight 4 will now be the least. So, picking the answer, now let's move on. In summary, let's check these 3 statements. All objects fall with the same speed, provided no force is acting to reduce their acceleration. No. All objects fall with the same acceleration, provided no force is acting to reduce their acceleration. I can say yes, because even a stone and a feather will fall at the same time, provided there is no force acting on them. All materials fall with the same velocity, provided no force is acting to reduce their speed. That is force. So all objects fall with the same acceleration, provided no force is acting to reduce their acceleration. Let's see. Yeah, good. We come to the end of this class today. Do well to subscribe to our website, www.edubbey.com, for more of our interactive notes and activities. Thank you for watching us. See you in the next class.